So hello to our last video in Vasari. Last time we've made our wind analysis and solar analysis. This time we'll make the last tool, which is the energy analysis in Vasari. So the energy analysis, first of all we have to know that we should choose a location like the climate analysis and solar analysis before, and we start by putting our floors. So we have here some buildings and a model in the middle, and this model has certain number of floors which I've made by adding new levels from here. Okay, so I started adding the floors. Now I want to make those floors appear in my mass. So if I go to analyze, I can see here different views, different energy displays, energy model displays. So the first one is show mass form, which is the mass like this, and then show mass surfaces and show mass zones. You will notice that those two are still in a gray mode, so I cannot select them. So if I want to select those modes, I go to modify mass from here. This one I've selected, and I start making my mass floor. Okay, so this will will help me in making the floors on my building here. So I start by ticking on each floor. Okay, so and then I press OK. You'll notice that the building here will have some new floors. Okay. So right now I have my floors, but I don't have any windows or any zones yet. So to make this happen, I'll start enabling my energy model here. So I press on enable energy model, and this is, by the way, this is the energy analysis tab, or this is a part where I do my energy analysis. So first of all I enable my energy model, and I wait until it's enabled. It might take a while because it's a big building here. Okay, I'll skip this warning now. Okay, so now I have my building. I have my floors and my windows too, and as you can see here, the energy model display, it's now selected on show mass surfaces, and there's another mode which is show mass zones. If I select this one, okay, change the color of the building. It's just an indication to that each one is a different zone, and I can select each zone independently, and you will know later how to deal with this. So if I come back to show mass surfaces and I select my building here, you'll notice here that there are some data that I can change. Like for example, if I want to change the mass floors, I can edit the mass floor from here. If I want to decrease or increase some of my floors, like for example this, I have double heights here. These two floors now are double height. I can start by making this model have different parameters. I can change the parameters of this model. So if I go to energy settings, okay, I select energy settings, I'll find here some parameters and some values that I can change. For example, the building type, if it's an office or is it something that's connected to the university, so it has to be a school or university, for example. The location of the building, okay, this is one I've changed it last time. The ground plane, okay, this will be level 1. Here I have some other parameters which are concerning the energy model itself. So first of all, the analytical space resolution and analytical surface resolution. Those are the resolutions for when I'm making the energy analysis. As I increase them, I'll have a better resolution, but we prefer that we keep them as the default values here. And if you want to know more about those, I'll put a link in the description below to understand more about the surface and space resolutions. Okay. Then the parameter offset, and this one is related to the if I have inside my building here like a core zone, and it is divided into several zones from the outside area. So I have an inside area which is a core zone, and other areas here which are the outside zones which are connected to the outside facade of my building. So here the parameter offset is adjusted to 5000, and notice that the building here, it won't reach a 5000 in the parameter. So if I decrease this number, for example 3000, if I decrease the parameter offset to 3000 as I've made here, you'll find that I started to have more zones, not only one zone for the whole level. I have multiple zones and inside the core zone of my building, and this will help me more in when I'm analyzing different types of zones. Not only if I have an university building, it's not only about libraries or about classrooms. I have different multitask zones, for example. Okay, so this is a parameter offset. If I change the offset, it will increase or decrease area of my zone. And this option here is whether I want to divide the parameter zones or not. If I select this one, I untick this button, I'll have one zone in each level. Then I have conceptual constructions. Conceptual constructions are they're trying to, here in Vasari, we're trying to make the building as real as possible, though it's a conceptual model, but I want to start putting different materials in different model elements. For example, the mass exterior walls, I can select many types of construction material, and so on with other model elements. So for example, if I want to change my windows, okay, if I want to change my glazing here, mask glazing, I can select another one, maybe not a double clear glass, maybe I can select a triple pane clear glass, and so on with all the other construction or model elements. And I press OK. I have the percentage of glazing, and unfortunately this percentage of glazing is uniform throughout the whole zones or the whole area of the building. So if I select 40%, all the facades or all the orientations will have 40% window to wall ratio. So if I increase this ratio to, let's say, 70%, and I press apply, you'll notice that the building windows have grown into a larger scale. They take nearly the whole area of the building, all the area of the building. Okay, the sill height of the glazing, and whether the glazing have a shading device on it or not. So if we have a shading device, we can tick this button and determine the shading depth, and in the end we have the percentage of skylights. If our building has skylights here up on the roof, we can put any percentage, and we have skylights distributed on the surfaces. Of course, it's not very it doesn't have many options here. So if I select a certain percentage of skylight, it will start to put skylights uniformly on the building. It won't have a shape that you want, or you cannot customize this skylight. Okay, as you can see here, it started putting skylights in a very. So as you can see here, the roof is filled with skylights. Okay, you cannot customize this skylight for unfortunately, but it gives you a rough representation of how the energy will differ with different percentage of skylights. Okay, and you can change the width and depth of the skylight. So for example, if you want one skylight on the roof, you can start adjusting this number to match the skylight that you have. For example, 4,000. So now that I've increased the number to 4,000, each skylight has a 4,000 of width and depth. You can see here that the roof has only 2 skylights. In the end, there's the energy model building services. This part considers the scheduling and the HVAC system. So for example, if you have a schedule of a facility that works 24/7, which was this, or if we have it working on 12/7, which works 12 hours per day but 7 days of the week, or we have a K-12 school, which is from kindergarten to grade 12 school, and you have different, as you can see here, you have different here schedules. So you have to choose a schedule that suits your building schedule. Okay, and the HVAC system. So we have several types of HVAC systems. Mainly on the university campus, we use VAV, central VAV, which is a variable air volume HVAC system. And if you want to know more about HVAC systems, I'll put a link in the description below for more information about the HVAC systems. And in the end, we have the outdoor air information. The air information, which is how much air that how much outdoor air does the person need inside the building. So this number would be fixed for 7.08 liters per second. Okay, and then we press OK in the end. And now we have our building ready for simulation, and this is a basic way to do energy analysis. So if you want to make more sophisticated energy analysis, you can start choosing the mass zones, show mass zones, and I can start selecting each zone by itself. Say for example, I have this part of the building has a different function than the other areas or the other zones. So I can select different zones. For example, this zone and this zone, 3 or 4 zones like this. Okay. Now I have selected 5 zones, and I can start for changing here from the options some different parameters. So for example, here's the graphic appearance, the materials and finishing. If I want to change the material of this zones to make them unique, I can start doing this. Okay, this is just for visual preferences, or I can start changing stuff about let's say the energy analysis here. So I can change the space type, and as you can see here, it's written building, so it's the space type is related to the building, which we chose before the building type, which was the schools and universities. We can change this into other types. For example, we have those are our laboratories, for example. So we can change this from here, or we can laboratory office, for example. And we can change the conditioning type, if whether it's heated or cooled, or heated and cooled, or unconditioned or ventilated, or whatsoever. And this depends on how you want to make the building. Preferably in a place like Fifth Settlement, we would use the heating and cooling part, because in the summer it's very hot, and in the winter it's sometimes very cold, that you need heating. Not only the HVAC system wouldn't be only a cooling system, it would be a heating system too. And then we press apply if we want to change those changes to those zones. Okay, so now those 4 zones, which I've given them another color here, they are now the labs of my building, and the other zones are the default, which is university building type. Okay, now I'm ready to make my simulation. So to start my simulation, I run the energy simulation from here. And now I press run energy simulation and wait to see what will happen. Okay, so now this window opened, which is run energy simulation, and I name my simulation, let's say tutorial 4, and I create a new simulation, and the project name is called, let's say, Part4, and we say continue. So now after I've pressed run energy simulation, I can start seeing my results, and from here the result and compare button. And as you can see, here are some of the analysis that I've made before. One of them is one I've just made, which is part 3 tutorial 4, and you'll see that there is a percentage here, 98%, which is it is running the energy simulation right now, and it's processing the data and making the results. So you have to know that the energy simulation and the solar radiation are made on the internet. They're not made on your PC, so you have to make sure that you're connected to the internet. Now we'll leave it until it reaches 100%, and we'll start seeing the data. Now the data is ready. You can see that they're giving us a screenshot of our building. Okay, this is the report, and it starts with the building performance factors, the location, the weather station, temperature, floor areas, the number of people, that depends on your building type, energy use intensity. This is the start of the overall energy analysis results. Here, as we can see, first thing is electricity energy use intensity, and how much electricity that we use per square meter per year. So as you can see, we're using 240 kilowatt hour per square meter per year. The fuel energy use intensity, and the total energy use intensity, converting the electricity plus the fuel into this number. And then the life And then the renewable energy potential. So if I have any PV systems, which are the solar panels, photovoltaic panels, which convert light into electrical energy. If I have some of those on the roof, how much energy that I will regain. So this is energy consumed, which is energy use intensity, and this is energy regained. Okay, but here you have to notice that energy use intensity is per square meter. It's always like that. If you see this definition, the energy use intensity, so you know that it's per square meter. SM for square meter, kilowatt hour per square meter. So those are the renewable energy potentials if we have low efficiency or medium efficiency or high efficiency PV systems. And if we have wind turbines, how much energy will we get from the wind turbines? Another important graph is annual carbon emissions. This is how much carbon dioxide is emitted from our energy consumption. So as you can see here, we have first thing is the energy consumption and the fuel consumption. And by the way, the fuel consumption comes from the HVAC heating system. Okay. So if we're here assuming that our HVAC is heating by using natural gas. This is the fuel that we're using here. So the energy consumption plus the fuel consumption are the total consumption per year of or the total annual carbon emissions per year, and the roof PV potential of high efficiency is in a negative value, because this is how we compensated the use of energy from the grid system, which is not renewable energy, and how when we use renewable energy this will compensate the amount that we're using. So that's why we make it minus 40, and we get in the end the net CO2 emissions. Okay, so after that, annual energy cost per cost, we have the electricity and the fuel, and as you can see that 75% of the energy use cost is through electricity. Okay, and this is the total number of energy use, which is 694,000 kilowatt hour, and we have to start comparing this number with other models or other design options that we're gonna make. We're not gonna make only one design option. We're gonna make several design options for comparing the best options and selecting which has less energy usage. Okay, and this is the energy use of only the fuel, how the fuel is located. So some of it is located into the HVAC system, and some is located into the domestic hot water usage. We can neglect this part, or we can start adjusting this part to make it in electricity if we're using electricity to heat water. So we can put this into the electricity part. Okay, and the energy use per electricity, the HVAC system uses too much energy, as you can see, and the lighting uses some energy, and the other equipment uses some electricity. And we can start converting from megajoule to kilowatt hour. You can see the conversion from the internet if you write it on Google. If you want to make the domestic hot water as used in electricity. And here the other graphs. Here is this graph, which is a monthly heating load. This shows you how much heat you gain and how much heat you lose in your building. Okay, so as simple as this, you can see here that for example, we gain heat from the equipments, the light fixtures, the occupants, and window solar, which is the glazing that we have. Okay, while we lose heat here, we lose heat, okay, through the window conduction. Okay, we start losing heat when we have infiltration, which is having air infiltrated inside the building, and through the walls. Okay, we start losing heat, and it's very common sense that yes, we lose heat when it's in January or February. We lose a lot of heat through the walls. Okay. Well, this graph, which is the monthly cooling loads, it's the opposite. So now we're, as you can see here, this is the amount of cooling that we have to do to compensate the heat gained. Okay, so now as we said before, we gained heat from the occupants, from the from the window, from the equipment's light fixtures. So we have to compensate this number to get to get to the comfort zone of the occupants inside the building. Okay, so for example, in June, July, and August, as you can see, the 3 high months here, the 3 summer months, we have to get nearly like 350,000 megajoules to from our HVAC system to compensate this heat. Okay, this is the monthly fuel consumption, and you can notice that it in the summer it becomes it declines to a number here that that's obvious because we don't use the heating HVAC system in the summer, but maybe we use hot domestic water if applicable. And the electricity consumption, of course, we find that the HVAC is working at full capacity in August, for example. Okay, and then we start having other graphs. Some of them are like the windrows, as you can see here. You can use those windrows if you want. The average temperatures of the year. Okay, so those data are not related to our energy analysis, as in how much energy is consumed. Those data are they are complementary or makes you know in which range that the temperature is, or if you want to know the wind direction in the other in months of the year, for example. So we have humidity, we have weather averages here, annual temperature bins. Okay, and that's it for the report. So this is our final report that we have. We can export this report to a PDF, for example. Okay, like this, I export it to a PDF. And we can open the PDF anytime to take, whether you want to take the screenshots, if you want to take the numbers and you make your own graphs, it's all applicable. And if you want to start comparing between other graphs, for example, energy analysis compare, you can start comparing those graphs. Okay, so I've chosen those two buildings, and then I press compare, so I can compare between the different as you can see, the different graphs here. can know which one uses more energy, for example, that this option is better than this option. For example, here the net CO2 is 161 and this one is 183. I can see that here the energy use intensity per square meter is more, so this differs because those are two different buildings, for example. And that's it. You can start comparing between the different design probabilities in the same area and the same location. So that's nearly it in the energy analysis, and actually in the Vasari itself. That's the capabilities of the Vasari. So see you next time in other videos that will contain more about daylight analysis and other stuff. So see you next time. I hope you start working on it soon.